In most galaxies, stars, like planets, will orbit around an object of a higher mass. This object is commonly a black hole. The orbit of the star is determined by the mass lying inside the orbit. A more massive star is closer to the center of mass, with a smaller orbit than those stars with smaller masses. As Kepler's third law has shown us, the motion of stars around a common center of mass combined with the laws of gravity has led to the determination of the masses of stars orbiting around a black hole. The picture shows examples of different star orbits, those being a halo star and disk star. Both are common orbits for binary stars. Hypervelocity stars do not follow the typical orbit patterns that most binary stars do. Hypervelocity stars are adult main sequence stars. Most of these main sequence hypervelocity stars are in the intermediate mass. In perspective, they are about 3 to 4 times the size of the Sun. The picture shows the different size classifications of stars. Hypervelocity stars are smaller than the high mass stars, but larger than the middle star or the Sun. This picture is not an entirely accurate representation of the sizes of stars. A higher mass star is much bigger than the Sun, but the picture only shows it being slightly bigger. So, a hypervelocity star is 3 to 4 times bigger than the middle star, but not as big as the star on the left, the high mass star. A star will become a hypervelocity star when it begins to orbit too close to a supermassive black hole, like the black hole shown in the Milky Way galaxy. When it gets too close, the star will get ejected from the black hole with an extreme velocity. This velocity is usually around 2 million miles per hour. After being ejected, the star will get thrown out of the galaxy, sometimes drifting through intergalactic space. It is thrown through intergalactic space because it is no longer bound by the gravity of the black hole. This picture is an artistic rendition of what happens to a hypervelocity star. As you can see, the galaxy is the background, with the ejected hypervelocity star shooting away from the galaxy at an extreme velocity. Hypervelocity stars closely tie into the information of our course. It is a very new discovery, the existence only being confirmed in 2005. Correlating with our class, the stars were discovered by analyzing the spectrum of light produced by the star and the Doppler effect. This image displays the Doppler effect in the blue color of the star as it moves closer to the observer. It is showing the blue shift concept. When it starts to move away, it will show redshift. The Doppler effect is how astronomers have been able to find the speeds for hypervelocity stars as they shoot through intergalactic space.